Okay, here what we're going to do is we're going to solve two initial value problems. This is from Openstax Calculus. This is volume 1. What we're doing is, these are called initial value problems because we have a derivative, f prime, and we have what they call an initial condition. This part right here is called an initial condition. So what we're trying to do is when we solve, we're trying to find f. So we're given the derivative and we're told that f of 1 has to equal 1. Well, what I'm going to use is the power rule for antiderivatives. And in order to do that, I first write f prime of x as x to the minus 3 power. And so now when I take the antiderivative, I use the power rule, which says I add 1 to that exponent part. So I have x to the minus 3 plus 1, negative 3 plus 1, plus c. So therefore, f of x is equal to x to the minus 2 over negative 2 plus c. And I guess it looks better if I just write f of x equals negative 1 over 2x squared plus c. But what we can now do is we can find c. And how are we going to find c? We're going to use that f of 1 is equal to 1. So I write 1 equals f of 1. Okay, that was given. F of 1 is equal to 1 is given. And I go ahead and I plug in where I see x, I put in 1. And so we're off, we're moving along here, okay? So I have 1 equals negative 1 half plus c. And if I add half to both sides, I get c is 3 halves. And so therefore I find f, it's negative 1 over 2x squared plus c, but c is 3 halves. And you can check that if you plug in x equals 1, you'll get y equals 1. So it satisfies the initial condition. You can check if you take the derivative of this, you will get 1 over x cubed. So that's one. One down, one more to go. I'm going to go ahead and highlight the answer there. Okay, for this one, it's very similar. The first step is actually, I need to write these as a power of x. And I need to do it correctly. I almost did it wrong. So x to the 1 half, radical x is x to the 1 half plus x squared. And, so we're trying to find little f. We're given f prime, try to find little f, and such that f, when you take the derivative, equals square root of x plus x squared, and f of 0 equals 2. So when I take the antiderivative, I use the power rule for antiderivative. I take the 1 half and add 1, and I divide by that. And that's actually something that pretty often you do that in your head because it's a little neater. And I think people, if you start doing your homework, you'll get pretty good at adding 1 to a half. The problem comes up over and over. So I'm sort of spending a lot of time and space simplifying this. And I hope I have enough space here. Okay, so now I want to find c. So what do I do to find c? I use the initial condition that's up here. Okay, so we have this initial condition, f of 0 equals 2. So I'm going to use that. So I have 2 equals f of 0. And f of x is given above, but we have c, which we don't know yet. So I plug in 0 for x, and I get 2/3, 0 to 3 halves. I feel like I can just put 0 there anyway. But 0 to the 3rd power over 3. But especially as beginners, we're supposed to sort of show work. But so this is 2 equals 0 plus 0 plus c. So c is equal to 2. And just having said we're supposed to show work, did I show enough work there? So c is equal to 2 because everything else was 0 and disappeared. So then I replace c by 2. Why? Because I just found that c is equal to 2. So Maybe I should zoom out so you can see what I've been doing there. Okay. Then, good to go, right? There's the answer. What was that? That was weird. Alrighty. Okay, so where are we? We got that answer. So again, you first have to write everything as a power of x. You find the antiderivative using the power rule. Then how do you find c? You plug in x equals 0 into f, and when x equals 0, y equals 2. And then you see that c is equal to 2, and then you just replace c by 2 into your formula for f of x. All right, so finishing up, I'll zoom out on all this. And maybe too zoomed out. All righty, so that finishes that.